Hi, welcome to a graphical approach to limits notes. Now, last time when we were evaluating piecewise functions, we determined if something was continuous, and to do that, we looked at it from the left and from the right. Okay, that actually has a name. It's called finding a limit. Now, when we did it last time, we plugged in numbers and looked at the equation algebraically. This time, we're just going to look at a graph, and you're going to find that looking at a graph is actually very, very easy if you know what's happening. Now, we're going to find a left-hand limit, which is finding what's happening from the left, and a right-hand limit, which is finding what's happening from the right. Now, if the limit exists, then they have to be the same. Okay, so essentially, if the function is continuous there, the limit exists. Okay, and that's a slight example. Now, it doesn't have to be defined there for the limit to exist, and I'll show you that. But as long as it goes to the same value, the limit exists. Then we're going to look at the limit as x approaches infinity, which is forever to the right, and negative infinity, which is forever to the left. And I'll show you exactly what that looks like in all of these examples. So let's get started. If you look at example 1, it specifically asks for the limit as x approaches 1 from the left. You see this little positive symbol? The negative symbol. That right there. That means that we're finding the limit as x approaches 1 from the left side. Okay, because it's negative, it's not saying -1, it's saying 1 from the left. Okay, because it's a little exponent at the very top. So let's go ahead and find that. Okay, so for this first one, I'm going to look at 1, and its x is 1 from the left. So as we go toward 1, it gets closer and closer and closer to the y value 1. So the y value would be 1. Okay, now this plus right there means that we're finding it from the right. So I'm going to go ahead and do that. I'm going to follow the graph. All right, and as it gets closer and closer to 1, it's still at the value of 2. Now, 1 is not equal to 2. And as you look at the graph, you can see that those values are not coming to the same number, right? One's at 1 and one's at 2. They're not the same, which means the limit as x approaches 1 in general does not exist because they're not the same, and D and E is just fine. Now let's find the limit as x approaches infinity. Now infinity is as x gets bigger and bigger and bigger. That's going this way. Okay, so for this one, I'm going to put that in orange. It's going and going and going, and it's constant up there. So it's just going to be at 2, because as you continue going to the right, the y value will always be 2. It doesn't give any indication that it's anything else. And then finally, as x goes to negative infinity, that's what's happening as our graph goes to the left. Well, as it goes to the left, it's going down. Okay, because it's going down, we're going to call that negative infinity, right? Because it'll go down forever and ever and ever. And that's what we're doing with all of these things. Okay, let's do another one. Again, for example 2, we're trying to find the limit as x approaches 1 from the left. We know that because this is a negative symbol. So I'll go ahead and find that. Now as we come from the left, where you were using this graph here. All right, and as we go to the left, from the left to 1, we're finding that it's at -1 down here, right? Because that's the y value. So that'll be -1. From the right, I have to follow this function up here. Well, that's reaching +1. Now, is -1 equal to 1? No. And as you see, the graph is not going to the same value. And it doesn't matter where it's defined, right? Because you see this random point here. That's where it's actually defined, but that's not what we're talking about. We're talking about what's happening from the left, on the red, and what's happening on the blue, on the right. And because they are not the same, the limit does not exist again. D and E. And that's it. Now let's find the limit as x approaches infinity. So that means as it's going to the right forever. Now notice the graph goes down. Because the graph goes down, it's going to negative infinity. When you go to the left, let's look at the left, the far left side. That's going over here. Hey, it's going up. Well, that means that the limit as x approaches negative infinity is positive infinity because it's going up. And we're essentially talking about the y values for all of these things. We're wondering what's the y value there? Okay, let's do another one. There are quite a few more. Let's find the limit as x approaches 1 from the left of this function. Okay, well, if I'm approaching it from the left, that means we're coming like this, right, from the left, and it gets closer and closer to 1. All right, so that's 1. The blue, so from the right, we're over here, I'm coming from the right, getting closer and closer to 1 from the right. Well, that's going to 1 too. All right, well, because they both end up coming to the same value, then the limit is actually 1, because the left-hand limit is 1 and the right-hand limit is 1. Because they're equal, the answer is 1. And it's not actually defined there. If you look, that is an open circle, right? So because that's an open circle, that has no impact on whether or not the limit actually exists. What matters is that from the left it's going to 1, and from the right it's coming to 1. Now let's find the limit as x approaches infinity. Okay, well, it's going down forever and ever on the right, so that'll be negative infinity. And if you look on the left, as I draw this, right, going to the left, it's going to go down forever as well. So that is also negative infinity. And there you go. Sometimes it doesn't look like that, though. Like here, that dotted line represents an asymptote. Okay, so an asymptote. Well, because it's an asymptote, we're trying to find, well, not because it's an asymptote, but the problem wants us to find the limit as x approaches 2 from the left. So we're going to approach 2 from the left side, which means this side over here, that's the left of 2. That's going to go down forever. Now we know from our knowledge of rational functions that it's never ever going to touch that value, okay? And really, it doesn't matter. We're talking about the y value. Okay, we're talking about the y value. So it's going to go down forever and ever and ever. That means that the limit is negative infinity. The limit as x approaches 2 from the right is going like this, right? And it'll keep going up and up and up and up and up. So that'll go to positive infinity. Now, is negative infinity equal to positive infinity? No. And because they are not the same, this is a does not exist. Now let's find the limit as x approaches infinity. Okay, well, that's going to the right. And we can't really see what's happening. We could assume that possibly it's getting closer and closer to 1. It doesn't specify. When you do your homework, it will be very specific. For now, I'm going to assume that it's going to be going closer to 1. Okay, because I don't have enough information otherwise to indicate otherwise. And this one, well, that's going to the left, right? As x goes to negative infinity, we're going to the left. And that could also be approaching 1 or maybe 1/2. All right, so let's put 1/2. Again, when you do your homework, it will be very, 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 very clear what number it's going to. All right, let's look at example 10. It'll be more like example 10. It'll be very specific, right? And you see those dotted lines. So first, let's find the limit as x approaches 0 from the left. Okay, don't forget, we've got to do numbers first. So 0 is right here. Well, that means it's getting closer to 1. That's the y value. From the right, hey, look, that's getting closer and closer to 1 as well. That's the y value. Well, 1 equals 1, and as you can see, that point is where the function is defined. So that's 1. All right, now let's find the limit as x approaches infinity. So infinity is over here to the right, forever and ever, and it gets closer and closer and closer to negative 2. So the y value here is negative 2. Okay, and sometimes it can do that. When we're going to negative infinity is on the left, right? So how far to the left is it going? Well, as it goes to the left, it gets closer and closer and closer to this horizontal asymptote at 4. So the limit as x approaches negative infinity is 4. All right, two more. These are a little weird. Hopefully by now, all right, after seeing so many examples, maybe the 0 from the left and the right are going to make sense. Right, so as I approach 0 from the left, it gets to 3. And from the right, it gets to 3 as well. So we have 3, 3. They're the same, so the limit is 3. Now the limit as x approaches positive infinity. Well, that's doing this little loopy thing, right? But as I get closer and closer to the right, that gets smaller and smaller and smaller and smaller. That's called an oscillating function. That means it goes up and down and up and down and up and down. But it's oscillating, which is the word we would use, toward a number because it'll keep getting closer and closer and closer and closer and closer and closer. Right? So that it's approaching that line. It's just going above and below over and over and over again. So it's actually going to 0. The y value here, that asymptote that it'll get closer and closer to, is 0. And you can see the same thing for the left, but it's going in closer and closer to 1, right? Because it's going around and around and around and around. Keep going. Okay, because it'll get smaller and smaller and smaller. So that's 1. Now sometimes it's not apparent what it's going toward, and so that's what this one's dealing with, example 12. Right, and yes, I did skip examples. So, 0 from the left, that's 4. 0 from the right, also 4. Right? Which means that the limit there is 4. So 4, 4, 4. Okay. Now, if you look at this, the limit as x approaches infinity, so it's going up and then back down, and 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 it keeps going up and then up and then up and then up. Okay, so it will get closer and closer together, but because it's going up forever as it gets closer and closer together, it's actually going to infinity because the y value will keep getting bigger. At some point, it'll keep getting bigger and bigger and bigger. Okay, now to the left, as x approaches negative infinity. If you look, we're going down, and then back up, and then down the same amount, and then back up the same amount, and then back down the same amount, and then back up the same amount. And if you were to keep going, you would find that it's going to go up and down the exact same amount every time, which means it's actually not getting closer to anything. It's going to keep going around. It's going to go up to 4 and down to negative 4, and then up to 4 and then down to negative 4, which means there is no trend. Okay? I mean, it's continuously going up and then down the same amount, but it doesn't get closer and closer to a particular number, which means that it does not exist. Okay, it doesn't get closer or anything. There's no value that it'll go toward. All right, and that is it. Have a great day.